Today we are going to try to talk about something that we should have talked about all this time. This thing that you see on your screen here is a drawing of a base and a column. Here we've got a drawing of a beam. Here we have a drawing of a slab. Okay, so today I'm going to be talking to you about how to design these elements. If I want to design a column, a base, a beam, and a slab, there are softwares that we use. First thing, I'm going to start with this one. It's called Procon. Okay, this is widely used in Southern Africa. Okay, now when we are designing, for example, for something called when we are designing for something like a concrete element like a beam, this is the example that I'm going to give. You click here where it says beam, RCB, which means concrete beam. This is a concrete beam. Here you can design a slab, a circular column, and other things. Okay, now we have another software here. It's called Study Pro V8i. Okay, now what I wanted to talk to you about is, as you can see, this software here, when you draw these things, they appear like this. This is the beam part. Okay, let me look at something else. This is the base. These are the bases here. Okay, then this is the ground level. This is just one of the beams that's been detailed. Okay, this software called Revit is only used for detailing. For you to do an accurate detailing process, you need to know the size of the steel that you'll be using. Let me double click here. Now here you can see I've got steel here. If you click here, you find out this is a Y12 bar. Okay, then we also have other Y12 bars in the other direction. Then we have, these are the links. The links, they are spanned from all this, from the way to the top all the way to the bottom. Okay, so to be able to come up with the right sizes for this design, you can use a software program. These are the column, the lateral reinforcement for the columns. These are Y16 bars. Okay, for you to know which kind of steel to use, you need to perform what are called calculations. Okay, so today I'm going to be just rushing into that. Okay, from the base, we've got a height of about 2.1 meters to the ground, where we have a link of beams. Then we go all the way to the top of this water tank stand. Okay, the water tank stand that you can see here. So the load is going to be applied here at the top. Then it's going to move to this beam. Then from the beam it's going to be transmitted to the column. Then the column, so that it does not buckle, it is then braced at the ground level there, and then the load is transmitted directly to the base, where it is dissipated into the ground. So if we choose to use we choose to design this beam here from this point to this point, you can see that it's 2 meters. Okay, this is not going to be a UDL, the load that is going to apply on this beam, because there is a law for beams that says load goes to the nearest support. So it is in this slide that you find out that the load for this one is going to be triangular when it goes into this beam. Okay, the UDL, the bending moment, the effect of the bending moment on the structure is different when it's coming from a UDL and when it's coming from a triangular load, and when it comes from a trapezoidal, even when it comes from a point load, the bending moment will be different. So I'll start with the 3D version of it, and I will show you why I prefer using this software. Okay, let's start with this software. The software that I'm going to use is called Study Pro V8i. Okay, the first thing is to create a new project, clicking here. Then I'm going to use a space frame. I'm going to click here. This is going to be file structure 1. Let's leave it like that. Then here I'm going to use units called meters. Then the other unit for force is kilonewtons. Okay, I'm going to click next. Now I'm going to be using add beams. Okay, then I'm going to finish here. Okay, this is the workspace that we are that we see. This one is a grid. Let me just start with a point. I'm going to create a point at 0, 0. Let's look at imagine a 3D matrix. Okay, if this point is 0, 0, if I'm going to move in the, as you can see here, there's an X, Y, Z. If I'm going to move in the Z direction 2 meters, I will just have to select this node. For me to select nodes, I go to this left ribbon here. Okay, this is a node cursor. I'm going to select that one. I'm going to then use that one to select this node destined red. Okay, I'm going to press Ctrl C to copy that node, then Ctrl V to paste that node. Now it's asking for the displacement, so I wanted to move in the Z direction by 2 meters, so I'm going to place here and place 2 meters. It's going in this direction, okay. So if I place 2 meters there and click OK, it's going to make another node. Okay, now we have these 2 nodes. They are right at the base, so I want to move these 2 nodes. I've selected them. Since I have selected this node cursor thing, okay, I'm going to move them in an upward direction. So for me to do that, I can use this translation repeat. To click on the translation repeat. Then I want to move it in the Y direction, which is the up direction. And click on the Y direction. Then I'm going to move it by 2.1. Okay, 2.1. I'm going to link it. Okay, now I'm going to add, press K here. Okay, as you can see, I've moved it at this point. Okay. I'm going now to select add beam. It's right at the left side. There's somewhere when it reads add beam. I'm going to click on that one. Then I want a beam to start at this node and end at this node. It only moves on nodes. Okay, now I'm going to select this geometric cursor. It selects members like this one. Okay, I'm going to repeat the translation repeat. I'm going to move this beam in an upward direction, so I'll select the beam. I'll go to translate repeat. I'm going to move it in the Y direction. I'm going to move it by 3 meters in an upward direction. I'm going to link it to the bottom and click OK. As you can see, it has moved 3 meters up. Now this thing is actually one side of the frame. When we are going to use the other software, which is Procon, I will show you there's a slight difference. Okay, so let me start with this one because it's going to give you a better idea of what I mean. Okay, I want to use a translation repeat. Again, I want to move it in the X direction by 2 meters. I'm going to click 2 meters here. I'm going to link it and I'm going to move it. Okay, as you can see, this point I want to delete because it's not joined at that level. I'll click on the delete button. Okay, I want to delete this one. Click on delete, then okay. Now I have a structure. Okay, this is a stick frame. It has no section properties whatsoever, as you can see here. I think I will just correct it just now. Okay, now I'm going to add section properties. The bending effect of this structure is affected by the material that is used to create the members. So in this instance, I'm going to use concrete. So I was at this stage. I'm going to go to geometry, which is where I was, and I made all these things. Okay, I'm going to save. Okay, then from there I'm going to general. Now when I get to this point general, I have property sections. This is when you assign the properties for the sections that you are going to. So I'm going to click here. Now when it comes to concrete, I'll use the define table. I want to click on define. Then I want to use a rectangular beam. Okay, this is according to that drawing that I was showing you, it's 0.3 by 0.3, which is 13, which is 300 millimeters by 300 millimeters. As you can remember, this is in meters. I'm going to add that beam. Then I'm going to add another beam. The Y part here is the depth of the beam. I'm going to change it to 0.6, which is 600, because that is the beam that I use. I'm going to add this one. Now I have it. Okay, let me close this section. I'm going to select on this this beam. It could be a column, but they name them as beams. So I select on the beams, then I go here to select, then I'll go where it says beams parallel to the y-axis, so that it selects the columns. Then I'll highlight the columns, and then I'll assign to selected beams. Assign yes. Right, this R1, that is the reference. Here is reference, that's why it's R1. If you go to this button here for 3D render, you will see that the section for the columns have been added, as you can see. Now we want to add the section for the beams. I'm going to select the beam here, then I'll go to where it says select beams parallel to. I'll go for the X ones, then I've selected those ones. I also want to select the Z ones, so I'll go beams parallel to the axis. I've selected everything. Now once I've done this, I want to assign the beams to the selected members. So this is a 0.6 depth by 0.3 wide. Okay, assign to selected beam, assign yes. Now if you can check here, you find out that all the beams are in place. You might be concerned with this bit of gap that is being left. The significance or the effects of that displacement is very negligible. You might choose to correct it by offsetting the beams and all that stuff, but it is insignificant. Now we want to move to the last part, where we are going to add the slab at the top there. So I will have to go to here where it reads thickness. I want to select that one. On the thickness, I want to put a thickness of 0.2, for example. Okay, I'm going to add that thickness, and I'm going to close. Right, this is the plate thickness, which happens to be the slab. It's considered to be a plate. Now I'll come here where it said add 4 nodal plates. I'm going to select that one. I'm going to add this node, that node, that node, and finally that one. Okay, since this is the only plate, I'm going to hit escape a few times. If we go to render view, you find out that there's really nothing. It's just a membrane. It has no thickness whatsoever. So I'm going to assign this thickness of this slab to the whole thing. So I'll select the thickness here, assign to view, so that it's assigned to everything. I'm going to assign it yes, it's done. Okay, now if you go here, you find out it now has a bit of volume. You can just orbit it a bit like that. It has now it has volume. It can now carry something. Okay, now we want to add the load here. Let's assume that we have an area load of 10 kilonewtons per square meter. Let's just make that assumption. You should be by now able to come up with the loading patterns and all that stuff. Okay, let's just do that. Okay, before I get to that point, let me go here to supports. I want to create supports, so I click on this support. Then I will look from the Z direction here, so that it's easy to select the support. Select the support at the bottom. If I go back to isometric view like this, you see I've only selected the supports. Then I'm going to create a support. I'm going to create a fixed support. I'm going to add that one. Then I'll select this support. I'll go back to this Z direction. I'll select all the supports that I want. Go to 3D. Let me save here. It's not a big deal. Now I'm going to assign this to select a load like this. That now it understands the structure that we are having. So it's going to do a bending moment analysis from this for the load that is going to this beam as it moves all the way down to that point. Okay, it can even it can even analyze the foundation. Okay, let me just move on to the loads here. So I went from properties. This one is used, I actually use it for my students, hence I'm not going to use it here. Okay, now I'm going to the loads. Under the loads, I want to create a loading. I'm going to add load. I will go to this load case detail and add. Okay, the loads that I'm going to add are primary loads. Let's look at dead load as one of the things that we're going to look at. So I'm just going to type DL for dead load. I'm going to add that one. Let me look at another load case, live load. Let me just change this one to live. It is important that you change it. Okay, I'm going to add that one. Then I'm going to automatically generate loading combinations. Okay, so this is the American. So I'm going to use this British one. Then since this one, this BS 5950 is for steel, I'm going to use BS 8110 for concrete. I'm going to generate that one. These are the loading combinations. I'm going to add those ones. Okay, I'm going to close. These are the loading combinations. Now when it comes to dead load, I'm going to select dead load. I'm going to add dead loads. Okay, the first dead load is self-weight. I'm going to select self-weight. I'm going to add that one. Right, then I'm going to go for area loads. I could go for member loads if they were loads on these particular beams. They are none, so I'm not going to bother myself with that. Let me go for floor loads. Okay, I say let's assume a dead load of 5 kilonewtons per square meter. So if it's going in the downward direction, I'm going to say -5. Okay, now it's global Y, that means it's going in the downward direction. Next, this is the range where this load, wherever it finds a plate, it's going to load it with this -5 kilonewtons. The minimum, let's let it be 0, which is right here at the bottom. Then this is going to be about 2 meters. Then it's 5.1 to this point. So the maximum, let's just go for 10 meters. Okay. Then once I'm done with that, I'm going to add this. Once I've added that one, it's now there. I'm going to close. Let me go to this live load. I'm going to add live loads here. Maybe I have a live load of a floor load by nature of, let's say, minus 2 kilonewtons. Global Y, this one, let's say is 12 meters. So it's going to add that load up to a height of 12 meters. Let me add that one. Okay. Now I'm going to select this load. As you can see, this has already been added. Now we don't have a plate here. There must be a problem somewhere, because we don't have a load at this point. Okay, so I need to adjust this one. Go here, I'm going to select this one. I'm going to edit that, so I'll move this one to about, let's say, 3 meters, and then change. As you can see, the load is only added at the top here. Okay, as you can see, like I said, load goes to the nearest. So this whole area, this load is going to that one. This whole area, this load is going to be that one. Okay, let me close that one. Let me go to this other one. I'm going to edit it as well, so that this is higher. Let me move it to about 5 meters. Let me move it to about 3 meters. Let me change this one. As you can see, it has been corrected. Okay, now we go to the self-weight. I'm going to assign it to view to everything that you see, since it's going to be affected or affected the graphic. Let me assign this one. Assign, yes. Now all of this structure has been affected by its own self-weight. Now what we have done, we have managed to create the loads, and we've managed to make it go through all this structure all the way to the foundation. So this is a 3D design software, so it's going to do everything else automatically. Now we have to go to, once we are done with this one, we go to material. As you can see, it's all concrete. I can select concrete and say assign to view, so that I make sure it's all concrete like this. Okay, now after material we hit general. Now we go to analysis. On analysis, we're going to select the no print for first use and say add that one, close. Once we are done with that, we are going to go here to analyze and say run analysis, then do our analysis. Now there are no errors here. There's something that is very key that I want you to see. Okay, let me explain. Let me go to post process. Okay, let me select that one. Okay, now this is what we want to analyze. We don't have to select everything. I have to remove this. There's no combination. I have to remove another one. There's no combination. Click OK. Now this is the structure as it's being affected. If I click here, you find out the bending moment has been the deflection has been turned on. Hold on the control button and then roll the mouse. You'll find out this is how it's going to bend under excessive stress. If you had eyes like a microscope, you'll find out this is how it's going to bend. Okay, now let me turn off the deflection. Let me look at something else like the bending moment. As you can see, this is how the bending moment will affect this structure. Okay, if you look at it here, this bending moment is going to cause a bending moment in the column. It's going to cause another bending moment in the lower beam here. It's going to cause a lot of moments all through the structure. So it is important to design the structure as a whole than to just design one element of the structure. I hope you are catching my drift. You get it? Okay, now let me look at something a bit different. Let me look at results here. I'm going to click on the view value, then I'm going to get to beam. I'm going to go for the end, for the midpoint, then the maximum. Let's just go for the midpoint and the end. I'm going to annotate. As you can see, these are the moments that we are going to face as a result of this stress. Okay, now let me just close this one. Okay. These are the moments that we are going to see at the midpoint, at the end point, and all that stuff. Okay, now we can use this data to do a design. Okay, before we go for that one, this was for loading. This was generated British BS8110 loading. Let's go for the envelope, which is the ultimate. The ultimate, we are imposing all the combinations that we have of loading cases. Then we print them one on top of the other. Then we come up with the worst case scenario. This is the envelope, as you can see. This is what we designed for. We look at the envelope and look at the highest values. Okay. I'm just going to go back to model here. Now, once we've done this, we want to do a design. Okay. Just in case, if you go here to the top and say select setup and click job here, you can write the name of the project, the client, and you can write your name here if you are the engineer, the one who's going to check the date when it was done, the comments that were made. Okay, right? If you've done that, this can be then printed out as a calculation sheet. That is the beauty of using the software. Now let's go to design. You click here and design, then you go directly to concrete. There's no steel here, it's just concrete. So I went to concrete here. I'm going to click here and select CP65. This one differs from the BS8110 in only 71 points. It's the closest that we have to the British standard that we use here in this app. Okay, now I'm going to use this one. Once I use this one, I'm going to click here and select parameters. These are all the parameters that we have. I'm going to deselect them. I'm just going to go for clearance. This is concrete cover, equivalent to concrete cover. FC is the same as FCU, that is the concrete strength. FY secondary, this is the reinforcement, the one that is used for links. Then this one FY main. This is the reinforcement that is used for main reinforcement. Okay, these are things that I want to change only in this exercise. So I'm going to click here. Okay, then I'll go to define here. The first one is clearance. So what is the concrete cover that I'm going to be using? Okay, let me use 0.025. I think there's a code in the British code there. There's some part of it that talks about concrete cover. I'm not going to go into that one, as I know you've already covered this. So I'm going to add this one. Now I'm going to go for FC. This is the concrete grade. As you can see, this is grade 30. If you change the units, it becomes newtons per square millimeter. It becomes 30. I'm going to change it to 25,000. Okay, I'm going to use a grade of 25. Okay, I'm going to add this one. Now I go to main reinforcement. As you can see, this will reduce a bit. Let me move it to 460,123. Okay, let me add that one. Let me go to the other one. Let me use 250,123. Okay, let me add that one. Now I think we are done with the reinforcement. I'm going to select this one. I'm going to assign it to view. Assign, yes, assign to everything. I'm going to assign this one to view. Assign to everything. I'm going to assign to view. Assign, yes. I'm going to go to this one. Assign to view. Assign, yes. I'm going to get the last one. Assign to view. Assign, yes. Now we are done. Okay, now we have put in the parameters of the material that we're going to use. It is now important to look at how we want to design. So I'm going to design for beams. I'm going to select beam design. I'm going to add that one. I'm going to go for column design. I'm going to go for that one. In this instance, I'm not really interested in designing the slab, but I think I should just do it for you. I'm going to add this one. Okay, now I'm going to close. When I select the beams now, I'll go to this selection, button, go to beams parallel to X. Then I'm going to select come to beam parallel to Z. Okay, I've selected all the beams. Then I'm going to assign to selected beams. Assign, yes. Now for the columns, they are seen as beams in this diagram. Okay, I'm going to go to select beams parallel to Y. As you can see, I selected that one. I'm going to assign to selected beams. Assign, yes. So this is going to be designed as columns. The first set is going to be designed as the beams. Now I'm going to go to this one. Now I want to select the plate. I can assign it to view since there's only one plate. So I'm going to assign it to view. Assign. As you can see, it has already selected this part. Now we are now done with the design. This thing is going to do the whole design in seconds. Okay, let's go. Before I do my design, I have to go to analysis. Then now I'm going to select all and add, then close. Then I'm going to go to analysis, run analysis, and then save this one. It goes through the analysis. It's now done. Okay, now I'm interested in the design, right? So let me look at the column here. If I want to design this column, if I double click this column, I'm going to see it says geometry. It talks about the dimensions, the properties of the column, the loads of the column. These are the loads, the various loads. I'm not interested in that. The shear force in the column. Let me go right to where it says concrete design. If you select that concrete design, you will find out here. Now we have the strength of concrete here. We have the strength of steel here, the strength of concrete there. Then we have the minimum reinforcement that is required in square millimeters. As you can see, it's well under 1%, and we have 8 bars. The reason why we have 8 bars is that the maximum between two bars apart, according to the British standards, is 150 millimeters. I think we can talk about that some other time, but that is the effect of the count. Okay, so this has done the design and it's finished everything. Let me select another column here. Let me go right to design. You find out this is the reinforcement that is needed. Okay, since the columns are similar, you have to find out how much reinforcement is this. I'm not going to go into that. I know you have learned about this one. Let me go for the beams, these ones that are carrying the actual load. Let me select this one. I'm going to go right to design here. You will find out you need 3 10mm bars on this left top part. The reason why we have reinforcement on this part here is because we have a hopping moment, like if you remember what we saw here. Okay, then at the middle here we have 3 bars right at the middle there, because that is where we have the maximum sagging. Okay, then this is what it's talking about. Okay, the length of the beam, then everything. So this is very detailed and very accurate. Okay, let me see. We need 3 white tins on this side, on this side, and this side, inside. Okay, let me close this one. If I was doing my detailing, and this was my collar, if I select here, this was my initial design, you find out I use 16mm bars. I have to reduce this one to 10mm bars like that. Then I will have to select these ones, I have to reduce them again to 10mm bars as per calculation. Okay. So the links here, you can find out from this, that if you double click here, you go to it with shear here, you find out that this is beam number 6. Okay, then we are looking at the shear and the reinforcement that we are looking at. We can't really tell from this point. Okay, we know this is beam number 6. Let me close here. You can select it from here. Okay, once you select it from this point, you go to results here, then you go to concrete. Then we said this was beam number 6, right? So we are going to go to beam number 6, which is this one. Look at it correctly. Okay, you find out this is beam number 6. The reinforcement that we are talking about is here. Okay, this is the longitudinal reinforcement, the main bars. Now this is the shear. We need 8mm bars spaced at 166 millimeters apart. Okay, we can't really find this. They normally come in multiples of 100 of 25. So I think 150 will be okay. Okay, let me just change to suit that. Okay, I'll come in, I'll select my links like this. I'll change the bar diameter to R, because I reduced the strength to R. Okay, 8mm. Then the spacing, I'm going to change it here to 150. Okay, just like that, and it's corrected. Okay, this is how you then adjust your structure. I can then look at the table and find out the reinforcement here. Okay, this was an eye-opener. I think this will help you to know how to design. You can actually look at this one. This is the reinforcement here, and how it's placed and how it's supposed to work. So if you want to change according to that, you can go here, you can go for the slab. Let me just do something much easier for me. Okay, let's look at this other beam. We go here, we find out we've got 3 white tins, and in this case it goes all the way through at the top there. Okay, I think we are done. Let me close this one. Now, in case you don't use that software, let's say you use this one. Okay, what are you going to do? You're going to select this beam. Now, when you have selected a beam like this, it's going to load this beam now here. Okay, with this one now, it does an element design situation. It's a bit different, and it tends to produce results that are not very accurate, as they do not take the whole picture into consideration. Here, where it's read FCU, you type in your grade. Let's say it's grade 25. Okay, here when it's read reinforcement, we are going to close this one. Let me just change this one to 460, and the other one I'm going to leave it as is. This one is from the center of the bar all the way to the nearest bottom cover or top cover. depending on where it is placed. Let me change this one to maybe 50 for this exercise. Let me change this one to 50. Okay, the way that it's calculated, we've got a concrete curve of 25, then we've got a link of 10 millimeters, that makes it 35. Okay, then the bar, we found out that it was 10 millimeters, so we're going to add 5 millimeters, so it's going to be 40. So actually it's supposed to be 40. Let me change it to 40. Okay, now these are the partial safety factors, as you remember. Now this is the creep coefficient. I'm going to talk much about that one. Here you read the name of the beam. Let's say this is the name. Then you go to section. Here you've got the first section. This is the cross section of the beam. The BW is the breadth of the beam, which is 300 millimeters. Then the depth of the beam, according to what we did, 600. Then we go to span. We've got the first span, which is span number 1. The length of the span is 2 meters. Then on the left side of the section we have section 1, and on the other side we have 1. Okay, if these numbers are the same, it means the section is consistent, right? We go to supports here. We've got the first support, which is on 1 here. We'll put it there. Okay, now this support is a depth of 300 and a breadth of 300. Let's say it has a height, because it's going all the way to the bottom there, a height of 3 meters to the next support, like that. As you can see, this is how it's supposed to be done. Okay, I'm going to go to the second one, which is 2. I'm going to copy these two things, crossing. I'm going to place them here. I'm going to paste them there. As you can see, this is the loading. Okay, now we go to the loads here. We are going to start with the dead load. You type in D, then the span, which is this span here, which is span number 1. Okay, now when it comes to this loading here, it's triangular. So on the left side we have a 0. Then on the okay, this is a bit difficult to draw. I wanted to create a triangular one. Okay, let me think what I'm supposed to do. On the left side it's a 0. On the right side, let's say it's a 5. Okay, then the distance in meters is the distance, as you can see, it's going from all this point to the other point. Okay, let's say it's starting at point 0 and ending at point 1. Okay, as you can see, this load it's only been added on one side. Now let's go for the other one. Is point, let's say this was 10 or 15 or 15, I think 15. Okay, as you can see, this is the pattern of the load, but it's not the end of the story. Okay, now we have another one which is starting at 0, which is starting at 15. So this one is starting at 15 and it's going to end at 0, and it's starting at point number 1 and ending at point number 2. Okay, as you can see, I created a triangular load. So this is a method that you can use to get the necessary loading and all that stuff. Okay, so you only look at the extra dead load. Okay, let's look at the live load. You type in L here. Let me just copy this, then I will change it a bit. I'm going to copy that, I'm going to paste it here. Okay, I'm going just to change these numbers. Let me reduce it to maybe just 2, and then here I'm going to put in 2. As you can see, the thing has been corrected. Now this is the loading. Once you are done with the loading, you go to view here. This is the deflection. Let's go to the bending moment. These are the bending moment. This is the maximum shear, the maximum moment that's going to suffer from. This is the reinforcement that will be needed for the support here, and right at the bottom here, right at the bottom at the mid span there. Then from there I go to reinforcement. Under reinforcement now I've got a beam type. Where it says 1, it's a normal beam. If it was a slab, I'll use 2. Things like stairs are slabs. Okay. Then there are various other types of beams. Then the maximum bar length in Zimbabwe will normally use 6 meters as the maximum bar length. Then the minimum bar diameter, let's use 8. Then the maximum, let's use 25. Then here the minimum, let's use 8. Then the maximum, let's use maybe 25. Then when it comes to setups, the minimum is 8, 25. The marking is here. Now we're going to generate. As you can see, according to my analogy here, we've got 2 bars here at the bottom. Okay, this is the calculation sheet here. So this one is more labor intensive when it comes to bigger structures, but it is easier to use for the unlinear. Okay, these are the 2 methods that we use to do calculations. Calculations are there to support the drawings that we are having. Like here, we looked at the column, the beam, the kind of reinforcement that we are supposed to look at. This is only important when you know the loading. So sound engineering is still important. Thank you for your time.